Okay, distance time graphs, homework 1. This is the easier of the two homeworks, so good one to get started with. Okay, so we've got a distance time graph in front of us. When you do see a graph on the question papers, it's always a good idea to check, is it a distance time graph or is it a velocity time graph? And of course we do that by looking at the y-axis. This one is a distance time graph. Next thing you ought to check is it divided into sections? This one is A, B, C and D. And just check that you can see where those sections kind of start and end. I'm drawing them in here, not very well because I'm on the iPad, and you can see that there's 4 sections here, A, B, C and D, and you can analyse each of them separately. Okay, let's move the screen up and have a look at the questions. Okay, for which section in the graph shows where the cyclist is waiting at a junction? Okay, so we're going to concentrate on this distance axis here, and we're looking for a period of time when the distance doesn't change. And you can actually see that here, if I actually rub everything else out of the way, here we've got a small section, section C, where even though 10 seconds has elapsed, the distance travelled has not increased. So he must be stationary at a junction. So I'm going to put C down there. How long did the cyclist wait? Well, we've got to read off of the x-axis for this one. So how long was he stationary for? Well, it started at 80, ended at 90, so that is 10 seconds. The section of the graph, which section of the graph shows where the cyclist is travelling fastest? Well, we know that the gradient of a distance time graph equals the speed. So I'm looking for a point on this graph where my gradient of one of these sections, which gradient is the steepest? And if I look, I think B has got the steepest gradient. So that means it's the fastest speed. So I'm going to put that in there. How can you tell from the graph the speed was the fastest? Well, that's because the gradient is the steepest. Now, obviously, write it as a full sentence. I haven't because I've not got my stylus at the moment and it's very difficult to write with my finger. And then the next question, how far did the cyclist travel in the first 50 seconds? Well, the first 50 seconds takes us to that point there. So I'm going to read from the y-axis, and he's travelled a distance of 200 metres. You can see that by reading the values off the y-axis. And then calculate his speed in the first 50 seconds. Well, my speed equals distance divided by time. That's an equation you need to remember. Distance divided by time. My distance is 200 metres. My time is 50 seconds, 50. Therefore, my speed is 4 metres per second. Let's just move the screen down a bit, and you can see there I need to put in 4 metres per second. Oops. Right, okay. Last part of the question, or this is question 4. Part of the journey was uphill. Explain which part of the graph is likely to show this part of the journey. Well, if we look at the graph, if he's travelling uphill, it's probably going to be going the slowest speed of the whole journey, apart from obviously when he's stationary. Now, if I look at D, the gradient is the least steep. So the gradient is the shallowest. That means he's going the slowest. So that's probably the uphill bit. So I'm going to put that down as D, because the speed is the slowest of all the sections. Okay.